Welcome back. We have a short week this week. Reminder, this is the first day of the second 9 weeks, so think of it like a game. We're in the second quarter, right? Y'all get your credits by semester. So if you pass the first 9 weeks, that's great. You want to make sure the second 9 weeks maintains, but I know y'all can aim higher, so aim high, please, okay? I want y'all to have a nice high first semester grade when we get to December, end of December, whatever. But if you didn't pass the first 9 weeks, no sweat. I'll talk to you about credit protection and about how to make sure you pass for the first semester. Anyone can do it at this point. There is hope for everyone, I promise. Okay, but we're gonna have a little plan. We'll talk one-on-one. You'll notice all of the assignments, I tore them down, and the only ones we have up are the ones that are rolling into the second 9 weeks. So the stuff we did last week is rolling into this grading period, which is the second 9 weeks. So you got slope-intercept forms, slope-intercept from tables that you need to make sure you are getting turned in for this grading period. In green, we have a quiz coming up, not this Friday, but next Friday, the 25th. So keep that on your radar. Last week's warm-ups, did y'all turn those in? If not, let's get those turned in. You have a Chromebook, holiday yesterday, today. You wrote down this phrase, which is linear regression for Desmos is, and then this weird thing, y1 squiggle. So this little phrase is going to be very important today because you're going to be able to take points and give me a linear equation using a linear regression. Okay, that's our learning target for today. Taking a table or 2 points, which can be made into a table, and turning that into a linear equation using a linear regression. Now, this said to go to Google Classroom and follow these little steps. Let me pull that up here. In Google Classroom, okay, in the stream, there's a little how-to guide here, okay? This is a nifty little website. It just shows you a website and tells you what to click. So look, here's a, it was nifty. One sec. There we go. Step 1. Now, when y'all are at Desmos, look right here. Everyone's eyes over here. See that top left plus sign? Okay. It's always been there. So when you go to Desmos, you click it. Then you get a little option that says table. Click that. And that's how you put in a table. So you start typing in whatever table I give you here. Click, click, click. Now this is where the magic is. Okay. You go down to this next input area and you have to type in what you wrote down on your warm-up. Okay, it's that phrase that looks like slope-intercept form, right? Except it's a little bit different. So remember, if you wrote it down, it's y1, and then it's that tilde, a little squiggle, mx1 plus b. Okay, that is what you're going to be typing to get a linear regression today. So once you type it in, okay, it's going to give you some information. It's going to give you m and b. Y'all remember that from last week? That m is slope and b is y-intercept. We'll get you caught up. Okay, we got notes in the back, right? But if it gives you m and if it gives you b, you can now write it as y equals mx plus b. What would the equation of this information be? Y equals 2x plus 2, right? And then the other bit of information we're going to learn about today is this R, okay? R is the correlation coefficient. I'll talk about that here in a minute because we got some mini notes and a little mini assignment, okay? So warm-up stuff is done. Let me pass this out. We are going to have paper notes, and you know how to get the link that I just showed you on the stream in the Google Classroom on how to do this. Okay, pass these back, please. All right. Now, my bad. Not that one. nothing. All right, so check this out, guys. First, let's talk about correlation, okay? So today we're talking about if you're given a bunch of points, okay? A discrete function, a set of points. Look at these graphs. So now y'all are looking up here. Everyone's looking up here, right? So look, first one, I got a bunch of points. Are they perfectly in a straight line? No, okay? But they're trending a certain way. So this is trending down to the right, okay? They're pretty close together. This is called a correlation, okay? So this correlation, since it goes down to the right, is a negative correlation. Go ahead and write that down for me, please. If your points are close together, trending down to the right, it's called a negative correlation. Negative correlation. Now in the middle, like it says, this is scattered points with no trend. Do you see how they're not all going up to the right? They're not all going down to the right. They're kind of just spread out, okay? That is not a correlation that we can discern. That's called a no correlation, okay? Make sure you write that down. And what do y'all think about the third one? What can it be? Positive is correct. As it goes up to the right, as long as it's trending closely that way, even if it's not perfectly in a straight line, that is a positive correlation. All right? So we got negative correlation, down right, no correlation, too spread out, and then positive correlation up to the right. Okay, so any questions on correlation? Now, we just went over this. Here it is printed out for you. The steps to do a linear regression. You need to know this phrase. Linear regression is what we use, okay, to find a line of best fit. Now, step one, like we said earlier, you click the plus sign, you click the table button, and you start inputting your table, or it could just be 2 points. Okay, very important. Whether it's a whole table, whether it's just 2 points, you're going to put it in to the table in decimals, okay? Step 3 here is you're going to type this weird thing. Now, doesn't this look like slope-intercept form? It looks kind of like y equals mx plus b, right? So y equals mx plus b. But what's different about it is we got to add the ones, right? And it's not equals. You got to use this tilde, squiggle, okay? Does everyone see how it's similar to slope-intercept form? But there's a few distinct things there. Cool. So again, you got to have this one and that squiggle. That's how it's different in slope-intercept form. Okay. Now, when you do that, if you look on your screen here, you end up getting this information. We said R is going to be that new piece of information, but we know M and B down here could help us write this equation. So if M is -2 and B is +2, my equation would be y equals mx plus b, -2x plus 2. Okay? Do you see how you can start with just even 2 points, linear regression, M and B, write the equation, okay? That's the basics of what we're doing today. Now, here's a little bit of new information, okay? Do you see the letter R, okay? Go ahead and underline a few things for me, okay? I meant to do this earlier, sorry. Going back up to that equation, go ahead and underline the phrase linear regression, okay? That is a phrase you have to know. what we are doing today is getting a linear regression. And when we get a linear regression, we find the equation of a line, and that line is called the, look right here, line of best fit. Okay? The line of best fit is is what we get when we do a linear regression. So let me bring it back up to those scatter plots. Look, if I drew a line through the middle of these points, right? Like I did my best to kind of like split the difference, okay? That would be an example of a line of best fit, okay? Because it best fits the information. Bless you. And if I could find that equation, that would be my linear regression. So that's what we're doing down here. Now notice, R is called the, go ahead and underline this, correlation, bless you, coefficient. Underline that, correlation coefficient. Okay. And that describes the strength and direction of a linear relationship between two variables. And this part is very important down here. If R is either 1 or -1, or really close to 1 or really close to -1, that would mean it is more accurate. If R is close to 0, that means it is not a really good line, okay? So, but as long as it's close to 1 or -1, you're good. Flip it over, let's try some practice together, and then that'll be it. Okay, so check this out. We got Desmos over here. Very important. When you do this, you need to have a blank Desmos to start with, okay? Always start over, okay? Clear everything else out. So what I'm going to do is put in this table. I hit the plus sign, table, 0, 1, 2, 3, 4, 5. Now, I know these are like decimal weird numbers, but you could still type it in. 209.5, 184.6, 159.6, 134.4, 109.6, 84.5. I typed in my entire table, okay? Now look, don't stay here. Go down to the next input and type what looks like slope-intercept form, but it's my linear regression. Y1 squiggle mx1 plus b. Do you see how a line pops up over here and then I get all my information? If you just put y equals mx plus b, nothing's going to happen. If you put the ones on it, it's still not enough. Okay, you gotta put the squiggle. Okay, so notice my equation is a bunch of decimals, but here we go. Y equals, now m is -25.0057. We can just put -25. X plus, and my b value is 209.548. I'm going to round to the hundredths place, 2 decimal places, okay? So I know I had to round, and I know the numbers aren't pretty, but that's it. That's a linear regression. My R value right here is -1. As long as it's -1 or +1 or close to it, then you could say, yes, that is accurate. All right. Any questions on that? Table, type in the regression. There you go. Now, what's weird about number 2? It's sideways, right? So I've had people mix up which one's X and which one's Y. So think logically with me here, okay? If X is the first column vertically, then it's going to be the first row horizontally, okay? So look, when it's sideways, the top one is X, The bottom one is y. Go ahead and put that here. Top one's x, bottom one's y when you're labeling them, okay? Okay, now remember, clear this out. I need all this old information gone. That way I can get the right numbers here. So I'm going to hit plus table. That first column is going to be the first row, 0, 1, 2, 3, 4, 5. And then I'm just going to put in all these numbers. You see them pop up on the table, in the graph. I'm going to type on the next input y1 squiggle m x1 plus b. And do you see on the graph, like it actually looks like it goes through most of the points pretty well? That's a good regression. And now I can write my equation. Y equals negative 1.1 x plus 13.9. My R value is negative 0.999. That's pretty close to negative 1, so that is yes, accurate. Cool. All right. Now, look, I know this is not on your page. Can you write this down? Okay, can you write this down? 2 points. Can you do it with just 2 points? I'm going to do that for you real quick. If I go to a table, negative 4, 5 is my first point. 3, negative 3 is my second point. I can still do y1 squiggle m x1 plus b. And it's going to give me my equation. So even if you just have 2 points. All right, so that's how you do these. You got to put in the table, do the regression, write it down. So I'm going to hand out this assignment. Use your notes, and you should be good. All right, here we go.